Today, I will share with you what I have been learning about Docker, and I would like to start with a thank you. So thank you to the organizer of this conference. I know how it's hard to organize a conference like this one, and I would like to thank you, my company, to support me, and to thank you to attend this talk. Uh, so Docker. Docker solved one of my biggest issues, and this issue is dependency. Dependencies are easy to add, but really hard to remove. So with dependencies, we have security problems, and dependencies are really hard to manage. Imagine how many softwares we have right now just to manage dependencies. Each language has one, and each Linux distribution has one too. So it's JS has two. But uh, dependencies is something that I don't like. And Docker gives me freedom to install, to test, to isolate the source code, and I can be free of these problems. And Docker organizes it in a way that it's easy for me to remove these dependencies when I'm not using it anymore. Uh, I want to show you right now how I use Docker in my computer. Uh, we can easily run a Docker image. Let's choose one image here, Debian. And I will execute the command inside the container. So if I run the ls in my computer, it will be this result. But if I run the command inside the container, this will be the result inside the container, because we are running this command in the root directory of the container. But when we run the command like this, Docker keep the image, the container here for you. So I run this command 2 times. Docker keep this container for me to use it, 2 containers here, but I don't want to keep these containers. The way I use Docker in my machine is I will start the container, I will execute the command, and I want to remove it. I don't want to keep this container running or available for me. And so this is what I call ephemeral Docker. So I want to create it, execute, and remove. And it's really easy to do that. You only have to specify one option. Let's remove these images first. So just to not be confused, temp, and the other one. So there's no images here or containers running anymore. And stop it, and what else? And we can run again with this option. So now there's no container here anymore. So this is really powerful. We can do a lot of things. Like we only need to have the image in our machine and execute any command that is inside the image. So I separate some examples here. In this first part, we use 3 files. The first one is a PHP file. So just print the date. Is it good to see? I can, oh, okay. So I separate a Node.js JavaScript file, the same thing, just print the date, and a Go file too. Just print the date in the terminal. Easy, right? So how it's possible for us to execute these files without have this language installed in our machine? So if I execute PHP, there's no PHP, no Golang, no Node.js. So there's nothing installed in this container. I'm running a container here, by the way. It's Docker in Docker. So, but imagine that I'm in my machine. I'm in my machine, but yeah, okay. uh, how can I execute these files? Because they are in my machine, but I'm running a command inside the container. How I put these files inside the container? So if we run PHP, oh, sorry, I'm just a little bit more ahead of what I want to show to you. Because I don't want to type every command every time in a complex way. Like, okay, I have to run Docker, run rm php now. Oh, sorry. And every time I decide to execute PHP, I have to run Docker and this. So in Linux environment, we can create alias. So I have some alias here that I created to run Docker in my machine, but I want to focus on those two, drun and drunv. They will do simple things. Basically, we'll execute ephemeral Docker. We will remove the container after the command. And the second one will mount the volume in /app of the current directory in the /app, and we'll move the work to /app. So when I execute the command inside the container, the files that are in my current directory will be in the container at the /app directory. So if I run drun php, is this, oh, v, sorry. It's the same of run docker run --rm, and there's no container here anymore. The second alias is dpa, it's the same of docker ps -a. So dpa, it will return this for me. So we'll type this drunv during the presentation, but you know what it means. So our current directory here, we have 4 files. One is date.php, and I want to execute this file, drunv php php date.php. That's it. I execute the file inside the container. There's no PHP installed in my machine. Oh, this alias is awesome. So we can do something that, like, I really like this thing. So I can do one alias for PHP, right? Alias PHP. And now I have PHP in my machine, date.php. Awesome. So really simple. Like, we are running a Docker command with an alias in your machine. So this is how I work in my machine every day. Like, I want to test something that it's easy for me to install on Ubuntu. How I test it? The run Ubuntu, and then I go to bash and execute whatever I want here, like install package, test software. If I want to share files that is in my machine, I mount with the drunv to mount the volume of the current directory, and that's it. I can access every file that I have in my machine to do whatever I want. So we can do the same thing with the Go file, the Node.js, just to show to you the example nodes and node date.js. We do the same thing with the Go. So golang, go run date.go. And that's it. It's really simple. Like, oh, okay, I need to test how my application or how this command will behave in a different version of PHP. So set the version. This version is PHP 7.3. So set the version, 7.2. And I have PHP 7.2 here. Now, it's really easy for you to execute any kind of commands. Okay, I want to see this in the browser. How can I do that? The run, I can set the port, and I will execute the PHP. So PHP, and it's PHP -s, right? Correct me if I'm wrong. 80, and we are running a web server here in PHP. How can I execute this container? I can just run one other alias to get the IP of my container, and that's it. It's here. My container is running. If I decide to run the PHP file, date.php, and it's not running. Cool. Because V, perfect. Thank you. That's it. I have to mount the volumes to put the files inside, and it's running. Perfect. So it's really, really, really easy for you to test anything that you want. And But this is related with the existing images. Sometimes you want to have like softwares or programs that you use every day. So, okay. So I installed one dependency in Ubuntu because I want to run this software. And when you destroy the image, it's gone. So tomorrow, you decide, okay, I want to execute this tomorrow again. Oh, I will have to install everything and test everything again. So to avoid this problem, you can use Dockerfile. So with the Dockerfile, you can define and install everything that you want and generate your own image for you to use anytime you want. So this is the Docker file that I separated in this example. Um, it's based on Node, and we install one Node dependency called TLDR. I will show you what this program do. So we will build this. I will call it node local. Oh, Docker is really fast. All right, build it. Amazing. So now we can run this command. There run node local TLDR and TLDR, just to show you what this program do. This program is simplified man pages. Like when you don't remember how to execute a command, you go to Google. How to do tar. But yeah, you can do here in the terminal. How can I use tar? And it will give for you some examples how you use the command. So sometimes when you open the man page, it's like a lot of information. Whoa, it's really difficult to read there. And you just want to know, okay, how can I extract a file using this command? And it's really easy. So there's this kind of things for almost everything, like PHP, what I can do with PHP. So you can run interactive mode, you can execute a file, you can build a built-in web server, and yeah, you can list all extensions, installed extension. We use this today, and it's easy for you to do that. So just to back to the presentation, the first part conclusion of this talk, we will now no more concerned about dependencies because these dependencies will not conflict anymore. There's nothing that you will install inside a Docker container that will conflict with your machine or with other container that it's running in your machine. So isolate. You have freedom to install and run any source code without care if it will damage your machine or your old libraries. And it's possible to version almost everything in your machine. Just create the Docker file and version in GitHub or whatever place you want to version it. So if you change your machine, just build the image again, and everything will be there for you. Perfect? The second part of this talk is about only one file, the Docker file. And it's about my passion about size and speed. I have this with me, like, okay, it have to be small and it have to be fast. And when I start to work with Docker and with Dockerfile and all the project, I have some problems. So the first problem that I faced, it was like, when I had different dependencies, I start to create like more than one Docker file per environment. Okay, so here I need Xdebug. So I will create one Docker file that has Xdebug installed, but I will not ship this to production. So I will create another Docker file for production without Xdebug, and I will build the Docker file for production without Xdebugs for production, and then I will build locally the one that I want with the extension. So problem. I don't want to have it. The second problem, send development dependencies to production. So if I keep this, I will, in one Docker file, I will have to send this to production. I don't want to send this to production. The same with the composer libraries. So I want to run tests locally. I want to run the tests in my CI environment. How can I install PHP unit, for example, in the same image, but I don't want to ship this to production? How can I manage that? Like, okay, in development mode, I want to have PHP units to run all my tests, but in production, I don't want to have it because I'm not running PHP units on production, right? You are not running PHP units on production. Okay. And the third problem is about create big, huge, and immense Docker images. Like you start and you are have fun, and oh, okay, let's install this extension, or let's install these dependencies, and you end up with like, yeah, gigas of images. Believe me, this is true. Like 1, 2 gigas of images. When Node is involved, man, yeah, you have big images. Uh, and again, we are talking about dependencies. And every time that we talk about dependencies, we have to turn on the headlight. I don't like dependencies. Just to show to you how dependencies is not good. This company is a security company. And they did like scan in Docker images to search for vulnerabilities. And these are results from March. And here we have a lot of vulnerabilities from the top 10 most downloaded Docker images. Notice there. Yeah. But the problem of these images, most of the time, is not the software itself, is the dependency. So let's look to the base image. So okay, let's go to the OS level and see what's the vulnerability in the OS level. We have Debian, and the small version of Debian has less vulnerability. What this means? Like, for me, it's really clear here. If you have less code, you have less problem, you have less vulnerabilities. It's easy. So if we go down, we have Fedora and Alpine here with 0 at the moment. I don't know how it's the situation right now. But based on that, I create my checklist. Okay, I have this scenario. What will be the perfect thing for me, and how I want to work with Docker in all my projects? So I would like to have only one Dockerfile, independent of my environment or what I'm doing. So I want to keep focus only in one Dockerfile. So it will be possible for me to clear see my dependencies. It's there. I don't want to put development dependency in production. I want to manage less dependencies. This means I want to install only what is necessary. And I want to create small images because small is good. We know that. Small is good. In these examples that I will show to you, I'm running Docker in Docker. All these examples, we will use standard Laravel project. So I created with Composer, create project Laravel. I choose Laravel because Laravel is what we use in Customer Gauge, the company that I work for. So, and all this example are running PHP has Apache module. Why? Because it's more easy for me to create a good environment to work locally and to work in the cloud. I don't have to worry about any other problems that work with Nginx and PHP FPM give me. And I'm an infrastructure that I can horizontal scale. So the problem that Nginx and FPM solves is not relevant anymore. I pre-download all images and I pre-built all images here. So because of that, the node local was really fast because everything was cached. if something goes wrong, it's because the cache is not working anymore. But I hope everything went good. So this is our first example. Um, we are creating this image based on the official PHP image, the PHP 7.2 Apache, because we are running Apache. We are copying our current directory, the Laravel application, to the /app, mounting the workd to /app. But here we have all the dependencies. Like, I need to install unzip because Composer needs unzip to unzip the package that Composer download. And I'm installing the PDO MySQL because if you want to interact with database, you can. And opcache. But this opcache is a production dependency, it's not a development dependency. So we start to have problems with this simple Dockerfile, and we are using the no-dev, so we will only install Composer dependencies that is not related with development. But if we decide to use this same Dockerfile in development mode, we have to install all the dependencies. So let's see how we can work with this image here. What we can do. Oh. So the image that I will work right now is this one. Okay, the same that is in the slide. So let's build this image. Docker build dot. I will call it PHP day PHP, and the Docker file is this one. Right? Fast. So if we decide to run this image, we can do the run p88 just to share the port, and PHP day PHP, right? Cool, it's running. Let's see if we can access this now. Ta-da, Laravel application, so perfect. Back to the code. If I decide to test this container, this software, the run, the same thing, PHP day, PHP, and I will try to run PHP unit. What will happen? There's no PHP unit here. So what I have to do? I have to install. Okay, let's install PHP unit. Now I will mount all the volumes here, and Composer is available for me here, so I can do Composer install, and we are going to install. And now we can run PHP unit. Ta-da! Green. I love green. Yeah, it's really nice. When it's Friday, it's better. Like green, Friday green is awesome. So see the problem here. Like, so every time I decide to interact with this container, I will have to install my dependencies. I will have to. This is not good. Like the way we are doing this, we are sending Composer to production. Who use Composer on production? Like, I don't know anybody that uses Composer on production. There's no reason to run. We only use Composer to download the libraries that we depend, and that's it. So we can improve this. And the way we can improve this, I'll show to you. So just to go to the checklist again, we have only one Docker file in this example, but we are sending dependencies, developing dependencies to production, like Composer, unzip, it's there. And we are not managing less dependencies. Like, we are using the official PHP Docker image, just to show to you how many extensions we have here, we can use the php command. And we have all these modules in the current PHP. And if we look at to the Dockerfile, I explicitly said only MySQL and not cache. But with the image that we are using in the front, I'm getting a lot of other things that I'm not managing to. So if there's vulnerability on those extensions, it will be a lot hard for me to remove or to do something. And the image is not small at all. So DI is Docker image, and PHP day, PHP. It's here, 400 megas. Far from 100, right? So not good. We can do better, I'm sure. So mute stage. What mute stage is? Mute stage builds are useful to anyone who has struggled to optimize Docker files. Me! While keeping them easy to read and maintain. Perfect. Perfect. That's what I want. So we can create another Docker file, but now using mute stage. And what mute stage is? It's when you use more than one from directive in your Docker file. But the beautiful thing of mute stage is that you have to be explicit about your sharing. So all everything that it's shared between all my applications. In that I can have my application running, I can have a process. So this is the place that I will put everything that's necessary for everybody. MySQL. I'm assuming that everybody will use MySQL. Yeah? Okay. Okay. Sorry. Let's try to do this. Dependencies. So here we have the first thing that we have to understand from the mute stage. We are creating this stage from the base because I gave the name of this stage. His name is base. And now I can reference this stage in other parts. So I'm creating another stage based on the base. And here I'm installing Composer, I'm installing the dependencies, I'm installing unzip, that is a Composer dependency, and it will be here, no problem. And then I have the CLI. The CLI is the stage that I use to run my tests, to run PHP artisan commands, to run anything that I want to interact with the CLI. So it's used for development. So I'm installing everything here. So I have all the libraries here. So PHP unit will be here. And all other dependencies that we have, we can add here. Like Xdebug, as I mentioned, and everything else. This example is really simple. And finally, we have the app. But the app, we are constructing the app based on the base, not based on the dependencies. So the only thing that we will have when we start the app is this thing, PDO MySQL, only this. And then we can copy explicitly using from dependencies only the folder that we generated. Imagine that you are working with like compiling things. Like when you're compiling things, you have to generate the binary. But if you will use only the binary, there is no need for you to all the dependencies. You can go there, okay, install in this stage. You install all my dependencies. You generate the binary for me. Oh, the problem. Wait, you can put in the table. Oh, thank you. You're a nice guy. No, this noise was, yeah. So here I'm explicitly copying this folder because we have all the files of the application and we have the vendor with the composer dependencies. And we are running up cache only here because this is the final thing that we will run for production, enable the module and give the permissions that Laravel needs. Perfect. Let's see how we can interact with this and how can we run and etc. Let's build the image first. Docker build. This one I will call PHP day multi. And perfect. And now I can generate another image. The thing is, we will have only one Docker file, but we can have more than one image. The only thing that I have to do is set the target. The target is the name of the stage that I want to go. So I will call it multi CLI. If we decide to run the PHP here, PHP day multi composer. So no composer inside this image. But if we decide to run composer inside the CLI, composer will be there. So we are sharing everything, and everything is in one place for us. So it's really easy to do. Like, okay, so I want to test. Vendor bin PHP unit. Cool, green. If I try to run this in the other image, there's no PHP unit. Perfect. I'm not sharing development dependencies anymore. Let's go to our checklist. So we have only one Dockerfile, and we are not sharing the development dependencies anymore. Cool. But we continue to not manage our dependencies because we can continue to use the PHP default Docker image, and the image continues to be big. So if we go there, PHP day multi, it's a little bit better, but yeah, it's not good. Of course we can improve that, right? And what we have to do to improve that, we have to change our base image. So the base image was our problem. And then I met Alpine. Alpine is small, simple, and secure. Beautiful. Love you. And then this is the final Docker file for the same thing. But if we go deeper here, we'll see. Now I'm splitting, saying, okay, I need JSON, I need MB string, I need simple XML. Those are Laravel dependencies because we are running Laravel project. So we need these dependencies. Exactly the same thing, install Composer for dependencies, unzip, install only the production's dependencies. And here we have one more thing that's nice. Like we are installing Dawn, XML, and XML Writer because these are PHP unit dependencies. But if in my application I'm not using these dependencies, why I'm shipping my application with these dependencies? And then the final application. We are installing the Apache, and I didn't mention about this copy Docker slash. This is the technique that we use to copy configuration files. I always create one folder called Docker, and I put the files, the configuration files, in the same structure of the Linux directory. So you only have to copy this specific folder to the root directory, and that's it. you copy all the files that you need to configure, like the PHP unit, the PHP ini configuration, the virtual host of Apache, and etc. We expose the port 80 and run the server, and that's it. Let's show you how it works. I'm lazy. You know, I like ADS, and I put things like in a short way. And Docker provides for us one thing that's called Docker Compose. So we can use it to help us to execute everything. So with Docker Compose, I can simply run Docker Compose build here. And that's it. Now I have all my images created and everything created. Let's see what we have inside my Docker Compose here. I have the app, so I give the name, so there's no need to specify the -t anymore. And I mount the volumes, I publish the ports, set the environment, and the same here. I can use target to refer to the stage that I want to build, and it's more easy for us to run like this. And of course, I have one alias for Docker Compose is DC. So DC build will be do the same thing. Like we will build this image. And if we decide to run DC app -d app, and it will run for us in port 80. Yeah, it's a lot of applications, so the same screen. Nothing to say. And we can run the CLI. So vendor bin PHP unit. Ta-da! Exactly the same. So you are making progress here, right? And let's check our checklist. Now, my checklist is complete. Like, we are managing less dependencies, and all the dependencies are explicitly. And we are creating small images. But let's see how small it is. di php day alpine. Unfair, right? 41 megabytes for the same thing. To run the same code, using the same tools, in the same version. So it's amazing. This is art. Come on, guys. Beautiful. Just to compare these images, so we have the PHP official image, the PHP official image using multi-stage, and I add Ubuntu here. Because, okay, we can do the same thing that we did with Alpine with Ubuntu. Like, if we can explicitly install only the extensions that we want and blah, 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 and blah, blah, blah. But the result's not the same. We end up with 200 megas. 43, 200, yeah. And I put the column of compressed image. Why? Because this is how your image will traffic. Like when you pull the image is compressed. When you push, Docker compress the image first, then push. So the time to traffic the image will be the compressed size, not the expanded size. So we have here 12 megas. It's like amazing. But of course, we have a lot of tools to improve this. And one of the tools that I want to show to you in this table is Minidoc. With Minidoc, Minidoc has minicon, importcon, and mergecon. With these tools, you can give a specific image and, oh my God. And then, it's possible to reduce the size of the image. How this software works? It runs strace and LDD in your Docker file, and only get the files that are in use. So if you are running Apache, it will intercept all the calls, see every file that it's open, and will keep only the files that you need for you. And you can generate small images from 400 to 92 is good, right? And it will continue to work, and that's it. Uh, if for you it's impossible to change your Linux distribution, or you don't feel comfortable to use Alpine, you can try to use some of the solutions. And to finalize the third part, everything that I showed to you here is to using my local environment. So how we can add this to CI/CD environment to build, to test, and to deploy. This is how is our current infrastructure in customer gauge. We have developers. We push the code to GitHub. GitHub triggers the pipeline inside Amazon. We use Amazon there. And this pipeline will run code build. The code build will build the image, test the image, push the image to the ECR. The ECR is the repository. And we will run a CloudFormation template to create any resource for us that is necessary to run this application. And the container is running a Fargate ECS cluster. So there is nothing to manage. Amazon manages everything. We just put the container there and use the challenge for us is to scale down and scale up and etc. So it's really simple to work with Amazon in that way. But Talkship, let's see how it is. Um, uh, what's going on? It's you, right? So I separate here the application. The application is the Laravel application and the infrastructure. Here we have 3 CloudFormation templates. This is everything that you need to run to create an infrastructure in Amazon and run a ECS cluster. So all the network part, VPC, private subnet, public subnet, and everything else. The ECS cluster, the Fargate security group, and everything else. And everything that is necessary to run the pipeline, like S3 bucket to store the code that we fetch from the GitHub, and all the IMI rules. Here we have the application. In the application, we have the pipeline. So the pipeline is the sequence. Let me show to you how the pipeline is. So this is the pipeline. We have the source. We fetch the code from GitHub. We have the build stage that we build the image and push the image to the repository. And we have the deploy stage that will create the container service inside the ECS cluster in Fargate. Oh. But the most important thing here is the build one. Yeah, it will be better. We use the same commands that we are running locally, but we are just moving these commands to the CI. Inside this code build, we are running Docker in Docker in the same way that we are running in my machine right now. So we use Docker build to build the image. We use the run CLI to run the tests. And after that, we just push the image. So it's almost the same thing, right? All these other lines are like just to have the commit hash to pass to the service, and here's the login in the repository. So we are logging to the repository. It's necessary because it's a private repository. But yeah, it's really simple. And here we have the application running there. So it's running. The time is updating, right? I create one file. Let me show you. This is my router. Uh, Date handler, and that's it. Return date with the current date. And yeah, it's running there. Everything that we do in Customer Engage, we use the DevOps culture. So everything is versional. So we have infrastructure as code. Everything is based on the cloud formation templates. So we never create a results manually. We never go to the console and create anything. So we always create the specific code for the specific microservice or for whatever we are doing. And then we execute this through the command line to create all the resources, and that's it. I want to show you one last thing that I was studying and I was dreaming about. It was okay, but yeah, ECS cluster, 5, okay, cool. I think it's perfect time. Um, I was dreaming, okay, but I can use Breath to run this in a serverless application, but all my workflow, all the way that I work, like I cannot use the same image. Like if I decide to use Breath, how can I test my application? Because now I will have to change everything to Amazon image because the binary is Amazon. So I will have to change everything to CentOS because now it's Amazon and change all my infrastructure to use this image, and I will have to generate layers based on my application. It's really, really hard. And I was, okay, but maybe it's possible to run Docker inside Lambda, no? And I start to research about it. How can I run Docker inside Lambda? So if, if I can run Docker inside Lambda, it will be exactly the same thing. Like I will continue with my pipelines, I will continue with my image, and yeah, it's perfect fine for me. It's not the ideal word, but it's possible. So I want to show you those two libraries. The first one is Scar. So this guy's creating a library to run Docker in Lambda. And I tested this library, and I will show to you the result right now. And these guys used one library called uDocker. With uDocker, you can run Docker without root privileges. So it's how it's possible to run Docker inside the Lambda. Everything is the API, so the guys just understand the API, the concept, and create this thing. How I run this is, if you remember, my image is really small. What I do is, I put the code of the image inside the Lambda function. So there's no pull or push. There's nothing, no network involved. The code of the image is inside the Lambda function. And when I start to study Docker, I was, okay, but this is directory gourmet. Because what Docker do is isolate files and folders, nothing else. So I'm sending my file and my folders to the Lambda function, and now I can execute everything. So basically, this is the configuration file, the name of the function, the image file, and here there's a bonus that I can call this Lambda function through the API gateway. So if you decide to create an API, you can do exactly the same. Here's the code running in Lambda. So the response is a little bit different because we have uDocker output, and it's take time. A lot of time now. See? It works. But as Matthew mentioned, the maturity of the Lambda functions to use in some cases is not good. Like if you can wait for this time to call your API, it's okay. But let's see how long it takes to call the ECS. Let's see the difference. And now the Lambda one. Yeah. Slow, right? So it's possible to do it. It's there. You can call it like in command line to do background jobs or to execute other operations that you want. But if you are trying to create something that it's really fast, maybe this is not the correct option. And you can easily scale ECS cluster to attend for your high volume of traffic when you want. So it's kind of serverless, but it's not. But I think it's good. It's how we work today at CustomerGate. And we are happy with this. So just the final considerations here. Care about security, care about dependencies, care about size and speed, and automate your process. Thank you. You can find me at Twitter,